I had first heard of this business of fighting fire with mathematics instead of Pulaski's from an old-time firefighter. He didn't think much of this as business and certainly didn't know much about it, but he said it was coming and was coming from a big building just next door to the Smokjumper base in Missoula. And he said computers did most of the work, which was counting. He said they counted burning sticks, and some of the sticks were homemade in the lab. He obviously saw no great future for this business, but oddly, he thought I should go out and take a look at it, and I did, because he was one of the best old-time firefighters in the Forest Service and nearly always what he said should be done. I did if it had anything to do with forest fires. Even before I went out to the fire lab, I had an idea, or what eventually turned out to be an idea. It was in the form of a somewhat smoke-obscured question. If mathematics can be used to predict the intensity and rate of spread of wildfires of the future, either hypothetical fires or fires actually burning, but whose outcome is not yet known, why can't the direction of the analysis be reversed in order to reconstruct the characteristics of important fires of the past? Or why can't the direction be reversed from prophecy to history? The one great tragedy suffered by the Smokjumpers was fading out of memory before its outline had been cleared of the smoke of controversy, before the missing parts, perhaps some self-cultivated, had been recovered, before its deferred trial had taken place in public court, and before its suffering had finally been placed within the reach of the public that would like to remember and honor it with sympathetic understanding. I can't say that the idea caught on like a crown fire, more like a spot fire. It started something that smoldered and kept growing, not of course without changing direction several times. It is fundamental for an analysis of a past fire that it should be attacked with a method that combines two methods, the predictive and the reconstructive. Prediction by its nature depends largely upon the scientific method, which, quoting Rothermel, usually conjures up an expectation for an answer to a problem that has somehow been arrived at by a logical deduction. In the case of fire behavior, the logic is supplied by mathematical models. When you change from prediction to reconstruction, you combine the 13 fuel models with every bit of information taken from observation, measurement, and the historical record. I don't suppose we were the first to make a serious effort to use this two-in-one method, the predictive and reconstructive combined, in trying to state as accurately as possible what happened in the critical stages of a complicated and tragic fire. But as a team, we were fortunate in the diversity of our specializations, and no combination of investigators would again have access to the only two survivors of the fire, whom Laird and I were able to persuade to return from far away to spend a day with us in Man Gulch. Now there is only Salih, and I doubt that he will ever go back again. Even so, it took us some years to analyze the tragedy of the Man Gulch fire by both predicting and reconstructing, because only recently has the science of fire behavior developed to a level where it is possible to analyze a legendary fire with any accuracy. There must have been a good many reasons drawing me back to the job, and certainly one of them was that. The more accurately the race between fire and crew is analyzed, the more it took on the form of a plot of a tragedy emerging from concealed to complete inevitability. The tragic convergence of fire and men in Man Gulch offers itself as a tragic model for a graph. The modern scientist's favorite means of depicting what he wishes to present as clearly as possible. Drawn along axes of time and distance is one line, depicting the course of the fire, and one depicting the course of the men. And where there is a convergence of the two, graphically speaking, is the tragic conclusion of the Man Gulch story. The two lines converging to this conclusion constitute the plot. Along each line are numbers, which are turning points in the race between men and fire, and if the lines are viewed as a race, the numbers mark off legs of the race. If they also have religious significance, they are stations of the cross, and if they have literary significance, they mark off acts of drama. If it is drama, it has the same old 5 acts as traditional drama, but the acts are much shorter, possibly because modern wildfire allows no time for soliloquies. The legs into which the race seems always to be divided seem always to be the same, as if mature nature had left natural markers there. The starting legs for the fire and the crew are different at different ends of the canyon and going in opposite directions. The remaining 3 legs, however, are almost an overlap of each other, the fire now being behind the men and getting closer. The coming account of the tragic race from start to finish is based on an unpublished paper by Richard Raw Thermal, which in turn is based on 32 pages of mathematical worksheets. By now you should know enough about how these mathematical woodsmen do business to be able to predict how these sheets are divided. The first big division is made up of 4 sections, a page or so on each of the most significant fire factors, determining the spread and intensity of the Man Gulch fire. Fuels, wind, slope, and fuel moisture. Fuels because fuel is the centerpiece of any fire and surely was of this one. Wind because a roaring wind virtually assures spot fires and a blow-up. Fuel moisture because the fire's tragic intensity was made possible by the super dry fuels and air that came with a long dry period and record heat. Slope because the abrupt increase in the grade of the slope near the top of the ridge was one of the reasons why the crew did not reach it. The second big division of the 32 sheets is entitled Sequence of Main Fire, and it is here near the end that a scientific analysis of fire and a literary analysis of it as tragedy comes closest to being one. In this section, each of the 5 legs has at least a half-page commentary pointing out the major change or changes occurring in that part of the race, each commentary being followed by a full page fire behavior worksheet with 23 entries available to characterize the changing conditions on that leg. It is not necessary, fortunately, to decipher all 23 entries to realize that scene by scene tragedy is approaching. Instead, let us take the word of our experts who say fuels are the center of the tragedy. If they are, we should be able to perceive a tragic continuity joining scene to scene and increasing in intensity as we follow the changes in fuels that the crew encountered as they attempted to escape. 1. The start of the race for the fire from point 13 to point 6. The fire had jumped the gulch near the bottom, which was narrow and overgrown by shrubs and conifer reproduction. The 2 fuel models that most closely fit the conditions of the bottom of the gulch are Model 10, timber litter and understory, etc., and Model 12, mixed conifers / somewhat compact. These heavy fuels under dry, windy conditions in Man Gulch would have created a fire of very high intensity, on the order of 400 to 1,000 BTUs per foot per second, with flames in the surface fuels from 7 to 10 feet high. Such conditions would generally have produced a very intense, although not fast-spreading fire, but the strong surface wind at the time would certainly have caused crowning and spotting, and crown fires with strong winds usually spread faster than surface fires and timber litter. The main direction of the fire would have also threatened the crew coming down gulch. Not only would the wind take it up gulch, but the slope would take it uphill. So on this diagonal side hill angle, it was on its way to head off the crew, which had not seen it yet. What the crew actually saw as it approached point 6 was black smoke boiling over a lateral ridge below and ahead of them. Black, boiling smoke is often what you see before you see the crown fire that's making it. The distance from point 13 on the map, where the fire jumped the gulch, to point 6, the turnaround, could only be estimated. We have already rounded it off to 400 yards. The location of point 13 involves some guesswork, if for no other reason than that no one ever knew how many spot fires jumped the gulch and took off. But the spot fire's location is not as important at this point as Dodge's estimate that the fire was still 150 to 200 yards away from the crew when he ordered his men to reverse course. Using fuel models and the fact that the fire had crowned, Raw Thermal estimates the fire was traveling at 120 feet per minute toward point 6. If we assume the fire was traveling 120 feet per minute and was still 150 to 200 yards behind the crew when it passed point 6, the fire would have reached point 6 in 4 to 5 minutes. That can be thought of as what the crew had in the way of a head start. 2. The start of the race for the crew from point Y to point 6. The location of point Y can be only guessed at. 100 yards up gulch from point 6 is close and keeps the arithmetic fairly easy. The foreman was somewhat concerned, as he should have been, but it was open hillside, and the men were moving gently on contour, or they could keep an eye on the flank of the fire. So they could keep an eye on the flank of the fire on the other side of the gulch. It would be fair to assume that they averaged about 3 miles per hour between points Y and 6, where they first saw that the fire was on both sides of the gulch. From point 6 on, time became a matter of minutes. 5:45 would be a good estimate of the time they reached the turnaround point at 6. There is hard evidence that at least some of the men were dying at 5:56. And the closer the race became, the more accurately both time and distance can be estimated. In something close to 11 minutes, the race was over. The turnaround from point 6 to point 7, this leg of the tragic race with the fire closing in from behind was the slowest. There is always time lost just in the mechanics of turning a crew around and getting it started in another direction. But the greatest loss was the loss that came in morale and organization in turning the crew around and retreating from the fire. The training schedule of smoke jumpers includes no class on how to run from a fire as fast as possible. The fire was having no organizational problems. It was gaining speed all the time. As it came upslope out of the brush and reproduction at the bottom of the gulch, conditions changed, and to analyze them, the fuel models must also be changed. Moving out of the bottom of the gulch, the fire came into more open country, with occasional large standing trees either alone or standing in groups. The grass, according to the survivors, was at least 2.5 feet tall. By August, cured like hay, and that would cause flames high enough to torch single trees and start crown fires in standing bunches. Using Model 3, cured tall grass, Rothermal calculates that the fire now had accelerated to 280 feet per minute, and that its intensity had increased to 2,500 to 4,000 BTUs per foot per second, with flames from the surface fire 16 to 20 feet high. The slant distance between point 6 and 7 is about 470 yards, and Dodge says that at point 7 the fire was only 75 to 100 yards behind them. Rothermal's estimate of the vital statistic at point 7 follows. If the fire were traveling at 280 feet per minute, it would cover 100 yards in about 1 minute, so the crew would have reached point 7 1 minute ahead of the fire, or at 5:53. The elapsed time between point 6 and point 7 was between 5:45 and 5:53, or 8 minutes, a pace of 176 feet per minute, or 2 miles per hour. That's the slowest time the crew made in any of the legs of its race with fire. But it's not surprising when one considers the leakage of precision that occurs when a crew has to be turned around and sent into retreat. And while the crew between point 6 and 7 averaged only 2 miles per hour, the fire already was getting ominously closer. And by the foreman's own estimate, in this quarter of a mile, the fire had cut the distance between them in half. No wonder that at point 7 he ordered the crew to drop its heavy tools, and when a firefighter is to drop his firefighting tools, he's told to forget he's a firefighter and run for his life. 4. Foreman lights fire ahead from point 7 to point 8. The leg of the race from where the foreman ordered the men to drop their heaviest tools to where he lit his escape fire is barely more than 220 yards. When figured as slant distance, it is the shortest distance between the stations of the cross, but it is the most critical in determining that the race would end in tragedy. This is the scene that makes the coming catastrophe inevitable, though it was not viewed that way by the tragic victims and not for some time by those who later studied it. As the men emerged from some standing timber to see their boss light a fire ahead of them, they were also looking at a broad expanse of something but did not see its significance. The fuel had changed and greatly increased the odds against them. Ahead to where Dodge was lighting his fire and even beyond, and above to the top of the ridge was a grassy clearing with only an occasional tree. It was the end of the earth for most of them who looked at it. They had come out of scattered timber with tall grass understory to an open slope covered with the flashiest of mountain fuels, cheatgrass and fescue, a mixture of short and tall grass and no timber, models 1 and 3. The up-gulch wind was probably about what Jansen a little earlier had estimated it to be, around 30 miles per hour, but the standing timber had kept it from acting with full force on the fire. Now it worked on the fire with the full force in the open. As a result, flames in the clearing would have been 30 feet tall. No wonder that Dodge spoke of what he saw only 50 yards behind him as a wall of flame. On the graph, the effect of the surface winds on light fuels is illustrated by the increasing steepness of the line representing the course of the fire. From point 7 to 8, Rothermal estimates the fire was traveling 360 to 610 feet per minute with an intensity of 5,500 to 9,000 BTUs per foot per second. At this speed, it could cover the 220 yards in 1 to 2 minutes and arrive at point 8 at 5:55 or 5:56. The men covered the 220 yards between point 7 and 8 in 2 minutes, a figure meaning that they had almost doubled their average speed between point 6 and 7. 4 miles an hour was terrific speed for the crew to maintain on that slope. At the turnaround, Dodge had estimated the fire to be between 150 and 2 yards behind the crew. At point 7, only 75 to 100 yards behind. Now at point 8, only 220 yards further, the fire closed the gap to 50 yards. Rothenberg's added testimony is that beyond point 6, the fire had to be going about 5 times as fast as at point 6, 660 feet per minute or 7.5 miles per hour.
Hey, bud, how
All right,
you doing?
good.